Okay, this is our chi-square goodness of fit test part 3. This is where we're going to actually run the test. Now, because it's going to be hard to show you on the webcam how to operate the calculator, I'll make a separate video after I do this. I've already run the test on this calculator. I'll make a separate video on how to operate the calculator where you'll have the calculator screen in the window. You'll see that. So what we're going to do first, we read the problem in the part 1 video where Fred believes there's an equal proportion of freshmen, sophomores, juniors, and seniors, so 25% in each class at his high school. His teacher thinks the proportions are not all the same. So we're going to run a chi-square goodness of fit test. We have to name the test. On an FRQ, if you have to run this test, this is what you're going to do. You're going to do all 5 of these criteria for credit. Name the test. Then the second thing you're going to do, we're going to check the conditions. We're going to make sure we have a random sample. That's given in the problem. If it's not given that the sample is random, we're going to have to assume that the sample that we have is a random sample. And we're going to have to state that in the conditions to make sure we're checking the conditions. The next thing we're going to do is we're going to make sure we say we're going to assume at least 600 students at the high school. We have to do that to make sure that our sample size is less than or equal to 10% of our population. And then the last one we're going to check is to make sure the sample size is sufficient, all expected counts. Now, if you say this, if you claim this, you better verify it. You have to show your expected counts when you're doing the problem. We're going to do that in the calculation part. You could do it here, but you have to make sure that all expected counts are greater than 5. Now our conditions are satisfied. Next, we're going to run our alternate or write our hypotheses. Our null hypothesis here is that the proportions, remember this is in context now, and different in words. You could list this out as P freshmen, P sophomores, P juniors, P seniors, all equal to 0.25. But most of our chi-square tests will be written out in words. So we're going to say the proportions of freshmen, sophomores, juniors, and seniors at Fred's High School are all equal to 0.25. We're testing Fred's hypothesis. We're testing his teacher's hypothesis. We're going to let the null be that there's equality, that we know what the distribution is going to look like. Then the alternate hypothesis is at least one proportion of freshmen, sophomores, juniors, or seniors is not 0.25 or is different than 0.25, not equal to 0.25. Those are our hypotheses. Next, we're going to do our calculations. For this test, because we do it so often, I'm going to let alpha equal 0.05. If they don't specify a significance level, I would choose 0.05. You can choose 0.01 or 0.1. Those are all 3 common. I wouldn't choose just some weird alpha. Degrees of freedom. I told you how to calculate that. Number of categories, -1. We have 4 categories. We'll take one away from that. That's going to be our degrees of freedom. The next thing from the calculator, we're going to get the chi-square distribution, or the chi-square test statistic. Chi-square test statistic, in this case, is going to be 2.4. I showed you how to calculate that by hand. The calculator does it also for you. And then we're going to get our p-value. And in this case, it's 0.493. Way bigger than alpha. So now we're going to move to our conclusion. Like I said, in our case, the p-values are greater than alpha. So we're going to say because 0.493 is greater than 0.05, there is insufficient evidence to suggest at least one proportion of, we want context here, make clear that you understand what's going on. Freshmen, sophomores, juniors, or seniors is different, or is not, than 0.25. And we fail to reject H0. And that's how we would get full credit for running a hypothesis test to test to see if there's evidence that suggests the alternate hypothesis, the teacher's hypothesis, that at least one proportion is not equal to 0.25. In the next video, I'll run a test on the calculator. It'll be a screen recording instead of a camera shot. So you'll be able to see the buttons we push on the calculator to get to actually run the chi-square test. Right now, I don't have time to do that. I got to go to church. But thanks for listening. This is part 3.